Okay, let us start with conservative and non-conservative forces. Earlier, we have studied about a work energy theorem in which a left hand part indicates net work done by forces and right hand part indicates a change in kinetic energy. But remember, there is another theorem which is very important from this subject point of view, that is the conservation of mechanical energy. And you might have heard conservation of mechanical energy is only applicable for conservative forces. And that is why we must understand about exactly what is a conservative force and which is called a non-conservative force. And you might have heard another thing also, a potential energy which is applicable only for conservative forces. There is no potential energy for non-conservative forces. So purpose of this lecture is to understand clear difference between conservative force and non-conservative force, and also work done by conservative force, how it is related with the potential energy. So let us start conservative force and non-conservative force. ओके बघा, आता आपल्या समोर दोन एक्झाम्पल आहेत. सो दीज आर व्हेरी टिपिकल एक्झाम्पल, कॉमन एक्झाम्पल्स. बघा, पहिल्या एक्झाम्पलमध्ये आपल्याला काय दिसतंय? येस, दिस बॉडी फ्रीली फॉलिंग ऑन दिस फ्लोअर. ओके, या फ्लोअरवरती तो काय फ्रीली फॉल्स and this body, again remember same body, suppose it is moving along the inclined smooth surface. So this surface, consider as this surface as a smooth surface. Okay, this is smooth surface, means there is no frictional force. बघा, दुसरा एक्झाम्पल मध्ये काय दिसतंय? दिस पाथ इज नाव, बघा याचा पाथ आपण असा केलाय आणि याचा पाथ जो आहे तो अगदी स्ट्रेट ठेवलाय. बघा, आता हे दोन जर आपण कम्पेअर केलं, यांचं वर्क डन जर कम्पेअर केलं आणि यांचं वर्क डन काढला, सो दिस गिव्स अ टोटल आयडिया अबाउट अ conservative force. So remember, in first case what happens? This block becomes, yes, freely it falls. So this second block is moving along the inclined surface. If you say same block is put on this and it is moving along the smooth surface here. So what is the work done in each case? In first case and in second case, what is the work done? आपण जर बघितलं तर what is the work done for this case? Yes, forces which are in the parallel. आपण वर्क डन काढण्यासाठी काय करतो? The forces which are parallel to the direction of motion. So displacement is this displacement in this direction, that is yes, displacement is in direction. mg is also moving downward, so both are having the same direction. So in such cases work done will be yes positive, and that work done is given by, okay, work done in first case, let us say, is given by this force mg into h. Okay, mg into h. But in second case what happens? In second case, remember, this component, weight component is there, mg sin theta. बघा, आता mg sin theta कसं येतं हे आपण आधी डिस्कस केलंय. So mg sin theta is what? So here this force is there, normal reaction. Okay, this is normal reaction but not contributing work done. So this component mg cos theta also not contributing work done, and surface is smooth, there is no frictional force. So only one force yes required for work done is mg sin theta. That component is there. So mg sin theta into displacement. So this is a direction of displacement. Yes, as this body coming downward, again work done is positive here as per the sign conventions. So work done in case 2, let us say this is mg sin theta, mg sin theta into its displacement. Yes, पण आपण जर ह्या थोडीशी जॉमेट्री बघितली इथे, there is a triangle, right angle triangle. This has a yes 90 degree here. So from this triangle you can write easily sin theta is equal to opposite h by s. So yes, h is equal to s sin theta. H is equal to h sin theta. So if you replace this s sin theta by h, we easily write mg h. So work done in second case is mg h. Remember, h is this height, or we can say this is a displacement difference between this initial position and this is final position. आता आपण जरा केअरफुली बघायच्यात, या पहिल्या केसमध्ये बॉडीची इनिशियल पोझिशन कुठे आहे? इथंच आहे. फायनल पोझिशन कुठे आहे? इथं आहे. या सेकंड केसमध्ये त्याच बॉडीची इनिशियल पोझिशन आपण इथे आहे अँड हिअर इट इज अ फायनल पोझिशन. मीन देर इज नो चेंज इन द इनिशियल पोझिशन अँड फायनल पोझिशन. म्हणजे काय सेम आहे, पोझिशन्स आर सेम. ओके, इनिशियल पोझिशन अँड फायनल पोझिशन्स आर सेम. द फर्स्ट थिंग इज व्हॉट, इनिशियल position is equal to final position. There is no yes in each cases they are same. Okay, so initial position and final positions are similar in each case, but what is the difference then? बघा difference observe करा. This पहिल्या केस मध्ये बॉडी कशी आहे, vertically down आहे, vertically it comes, means its path is what, its path is this is path. But in this case, this is a path. So there is a difference of path. बघा difference of path असून पण वर्क डन काय येते, सेम येते. म्हणजे mg हा जो फोर्स आहे, ज्याला आपण वेट म्हणू, ज्याला आपण ग्रॅव्हिटेशनल फोर्स म्हणू, या mg चा जो वर्क डन येतोय तो बघा पहिल्या केसमध्ये आणि दुसऱ्या केसमध्ये सेम येतोय. म्हणजे याचा अर्थ द कन्क्लुजन इज व्हॉट, द फर्स्ट कन्क्लुजन इज व्हॉट, वर्क डन बाय अ सच फोर्स that is mg not depends upon path. Okay, not depends upon path. It is not depend upon path. So path is different there, but still work done becomes same. Okay, let us take feeling of this particular example. Okay, baga, what happens here? So this block, yes, falling downward. Yes, this is falling downward and this is sliding on the plane. But baga, initial position, final positions are same. Here also same story. Baga, ithe diste tumhala initial position here same at initial position, and final is also same, but it changes the path. Baga, ithe asa L shape चा path झाला and this is also coming downward in this direction. So observe what is the difference. Difference is what? Yes, path is a difference here. Path is a difference here, and but remember, initial and final points are same. Initial and final points are same. So this is, म्हणजे इथे आपण काय ऑब्झर्व केलं की path is going to change here, but initial and final positions are remaining same. In second case also, बघा इथे height h1, so this height is h1 here, suppose, and this is h2, and this height is h. Remember, this h becomes h1 plus h2. बघा पहिल्या केसमध्ये पण आपण वर्क डन काढलं, work done in first case also. Okay, for separating this I'm just putting line. So work done in this case is mgh1, yes, plus h2, or mgh2. If you consider only mg force, which is parallel to the displacement, so we get this. So that gives us mgh1 plus h2, and that is nothing but mgh. And work done in second case directly becomes emgh. म्हणजे बघा कन्क्लुजन पॉईंट काय आले आपल्यामध्ये की बघा पहिल्या केसमध्ये आपण थोडा विचार करूयात. ह्याचा पाथ होता एकदम व्हर्टिकली डाऊन, ह्याचा पाथ होता इन्क्लाइंड, बट स्टील वर्क डन बिकम्स सेम. इन दिस बघा असा पाथ चेंज झाला मध्येच हिअर, आणि इथं पाथ हा अगदी व्हर्टिकली डाऊनवर्ड. बट व्हॉट इज अ कॉमन थिंग इज दॅट पाथ आर डिफरंट, बट इनिशियल पोझिशन अँड फायनल पोझिशन दे आर सेम. म्हणजे mg हा असा फोर्स आहे बघा, आपण त्याला काही नाव अजून देऊ नयेत, पण mg इज अ फोर्स which depends upon initial and final position of the body, but it doesn't depend upon its path. It doesn't matter about the path. त्याला path कसे असू देत, फक्त इनिशियल आणि फायनल पोझिशन वर डिपेंड असणारा फोर्स, अँड दॅट फोर्स इज अ वेट, or we can say gravitational force, and that gravitational force now onwards we can call conservative force. Conservative force. So conservative force is a force which not depends upon path, but depends upon initial and final position of body. Note down these two things. Conservative force depends upon initial and final position of the body, not depend upon its path. Path kasai asu det, conservative force, work done by conservative force becomes same. Now another thing we can observe, that is work done for round trip is what becomes. बघा वर्क डन फॉर राउंड ट्रिप व्हॉट बिकम्स. बघा आता राउंड ट्रिप म्हणजे काय, राउंड ट्रिप इज नथिंग बट व्हॉट, येस राउंड ट्रिप इज व्हॉट. बघा इथून स्टार्ट झालं बॉडी आणि पुन्हा परत तिथे गेला असेल तर वर्क डन काय येतं, म्हणजे दिस इज इनिशियल पॉईंट टू फायनल अँड अगेन कमिंग टू फायनल इनिशियल पोझिशन. ओके, सो वर्क डन इन दॅट केस व्हॉट बिकम्स बघा वर्क डन 1 आपण म्हणतो. सो वर्क डन फ्रॉम इनिशियल टू फायनल प्लस लेट अस टेक वर्क डन फ्रॉम final to initial. Okay, like this. So work done from initial final we have calculated. Body coming downward, yes, body coming downward, so work done is mgh. Then second case, body weight mg is downward but displacement is upward, so we have taken आपण बघितले sign convention, yes, it will be minus mgh. Okay, in first case what happens, this body mg downward, displacement also downward, but in second case mg downward but displacement upward, so that's why minus. So result is what? 0. So work done for conservative forces for a round trip for a closed path is always 0. हा प्रयोग तुम्ही incline block ला करून बघा. incline block ला आपण करून बघितला. W2 is equal to again same W2 initial to final plus work done final to initial. So that becomes mg sin theta into s and minus again mg sin theta into s. Why it is minus? In first case it is coming downward, so displacement mg sin theta component and displacement in the same direction, but in second case mg sin theta coming but displacement is upward, so again result is 0. So work done by forces, such forces ज्याला आपण आता नाव दिले कंझर्वेटिव्ह फोर्सेस फॉर अ राउंड ट्रिप फॉर अ क्लोज पाथ बिकम्स इक्वल टू 0. तर हे दोन प्रॉपर्टी लक्षात ठेवायच्या. फॉर अ कंझर्वेटिव्ह फोर्स वर्क डन डिपेंड्स अपॉन ओनली इनिशियल अँड फायनल पोझिशन अँड नॉट डिपेंड अपॉन अ पाथ फॉलोड बाय द बॉडी. अँड सेकंड केस वर्क डन बाय फोर्सेस फॉर अ राउंड ट्रिप फॉर अ क्लोज पाथ इज ऑलवेज इक्वल टू 0. तुम्ही म्हणाल सगळ्या फोर्सेसला असंच येईल का? No, there are other forces are also present which doesn't obey these rules. Means round trip work done is not equal to 0 there, and their work done is depend upon path also, and remaining, so such forces are known as non-conservative forces. Okay, so such forces are called as non-conservative forces. So conservative forces means depends upon initial and final position, not depend upon path, and work done by round trip is equal to 0. And non-conservative forces, yes, बघूयात आपण non-conservative forces ला. So these are the conservative forces. ओके, बघा आता आपण असं मोशन कन्सिडर करूयात जसं या बघा इथे दिसतंय, हा जो ब्लॉक आहे. सो सी फ्रॉम द टॉप व्ह्यू, सो येस इट इज मूव्हिंग अँड अगेन कमिंग टू द इनिशियल पोझिशन. सो दिस इज अनदर एक्झाम्पल ऑफ येस फोर्सेस. पण आपण इथे लक्षात घ्या, अशा केसमध्ये आपण या केसमध्ये जे पाहिलं, बॉडी इथून बघा इथे गेली, पुन्हा इकडे आली, पुन्हा इकडे आणि पुन्हा इकडे. सो एस डिस्टन्स इज ट्रॅव्हल बाय. सो हाऊ मच डिस्टन्स is traveled by this body is simply s plus s plus s plus s, that is a 4s. So let us think about a force that is which is called a non-conservative, nothing but, so that is a frictional force. बघा आपण थोडासा डिटेल याच्यावर विचार करूयात. बघा आता इथे डिस्प्लेसमेंट दिसते आपल्याला, हा डिस्टन्स बघा s आहे, दॅट इज अ हिअर फ्रॉम स्टार्ट फ्रॉम दिस. बघा आता याची फ्री बॉडी डायग्राम आपण काढण्याचा प्रयत्न करूयात. लेट अस ड्रॉ अ फ्री बॉडी डायग्राम फॉर दिस. So you know this is a body. Suppose आता बघा हा वरती जे दिसतंय that imagine that is a top view. बघा टॉप व्ह्यू वरून आपण बघितलंय, टॉप वरून बघितलंय आपण की हा असा यस ट्रॅव्हल केलाय, पुन्हा यस ट्रॅव्हल, पुन्हा यस ट्रॅव्हल आणि पुन्हा यस ट्रॅव्हल. सो फॉर दिस if this is a surface, okay, this is a surface, then which forces are developed there? So this is a normal reaction. बघा हा normal reaction असेल. So weight mg is there. Okay, weight mg is there, and remember this force, if displacement is in this direction, displacement, suppose starting displacement is in this direction, so there will be a frictional force that is mu k into r. Okay, mu k into r is a frictional force. आता ह्या फ्रिक्शनल फोर्स आपण काय करूयात, वर्क डन विचार करूयात. मग सर आपण काय काढलं होतं वर्क डन? येस, वर्क डन फॉर अ राउंड ट्रिप आपण काढलं होतं. वर्क डन बाय mg is becoming 0 in that case. पण इथे बघा, this is a top view, remember this is a top view, this is a top. Okay, top view मध्ये आपण बघितलं एक छोटी movement बघितली आपण. So this moving in this way. So first coming in this direction, again. So it becomes at initial position. आता या राऊंड ट्रिपचं वर्क डन आपण काढायला घेतलं. अगदी सिंपल विचार करा. बघा डिस्प्लेसमेंट या डायरेक्शन मध्ये, फ्रिक्शन इकडे असतो नेहमीच. इथे जरी विचार केला तरच असणार आहे. येस, डिस्प्लेसमेंट इन दिस डायरेक्शन, फ्रिक्शन अगेन्स्ट अपोजिट. हियर डिस्प्लेसमेंट इन दिस डायरेक्शन, फ्रिक्शन अगेन्स्ट अपोजिट, and here again opposite. So friction always opposite. So work done will be negative work done. So if you calculate this work done, let us consider these as a 4 path. Okay, let us consider this first path, second path, third path, and fourth path. Okay, so total work done is by this frictional force. Let us say this Fk, it is equal to what? Yes, whatever the force, frictional force, that is mu k r is everywhere constant into this S, which is minus mu k r into S, minus again third path mu k r into S, and last one is also mu k into S. If you take common all things, so it becomes minus 4 mu k r into S. So this is a work done by a frictional force for a round trip. Okay, this work done is for round trip. This is for round trip. So which is, remember, this becomes minus come Fk into S. Remember, it not becomes 0. This work done for round trip is not become 0. This is an important observation. For conservative force, this work, yes, we have calculated that work becomes yes 0, but here it is not 0. So therefore, such forces which are called non-conservative forces, example is a friction force, viscous force, any resisting force we can say, is always depends upon a path followed by the body. Yes, they are not, yes, initial position and final position here doesn't matter, but path matters. Path is very important. So for a round trip, work done not becomes 0 here. So in case of conservative force, the work done by conservative force depends upon initial and final position only, not depend upon path. But non-conservative force depends upon a path, is very important line, depends upon a path. So such forces are non-conservative forces. So conservative force and non. So now force is divided in another form now. So gravitational force, electrostatic force, intermolecular attractive forces are conservative forces. Friction force, viscous force in fluid mechanics, and any air resistance force, etc. These all are non-conservative forces. And now a key point is there. Potential energy is only related with the conservative force. How it yes, आपण बघूया ते how it is potential energy is related with only conservative forces during the potential energy lecture. But now for this discussion, the conclusion is what? What is a conservative force and what is a non-conservative force? So it is clear cut. There is a dividing line between conservative force and non-conservative force. Okay, so just revise it and then moving to the work done by conservative force. So work in conservative forces, work done does not depend upon path. In non-conservative forces, work done depends upon path. Work done in round trip is 0 in case of conservative forces. So example is our mg weight, gravitational force. In non-conservative forces, work done is a round trip is not equal to 0. So frictional force is an example of this. And other example of conservative are, yes, spring force is also example of conservative force. And for non-conservative concern, dragging force, viscous force are examples of non-conservative forces. And remember, in conservative forces, remember this one important thing, in conservative forces, work done is completely recoverable. So work done can be recovered. But non-conservative forces, work done is not completely recoverable. So these are the key differences between conservative force and non-conservative force. So remember only conservative weight, non-conservative friction. So let us move to the how to calculate work done by conservative force and how it is related with the potential energy. Okay, let us consider these two examples. In first example, this body falling. So body has a mass of 3 kilogram and it is falling. So at start its velocity is 0. Okay, remember its velocity is 0. So let us think about only a potential energy and work done. So work done for downward motion is what? So simply work done for a downward motion is given by, yes, its weight mg into whatever its height h. Okay, whatever its height h. It is falling with some initial velocity, and yes, this having a striking velocity that is 2 meter per second. बघा आता याच्यावर आपण वेगळं डिस्कशन करणार आहोत एनर्जी पॉइंट ऑफ व्ह्यू इन द कन्झर्वेशन ऑफ मेकॅनिकल एनर्जी. बट नाव ओनली थिंक रिलेशन बिटवीन द वर्क डन and potential energy. So work done is mgh. So let us calculate this value in some numericals. Okay, so let us consider this height as a 1 by 5 meter. For calculation purpose I am taking this such particular height 1 by 5 meter. So mass is 3 kilogram, yes, g is 10 and h is 1 by 5. So this value gives us 3 into 10 into 1 upon 5. Okay, this gives us 2. So remember, this is a 6 joule. And tell me, is it positive or negative? Yes, it is positive because see this direction of displacement downward, force is also downward. This force is nothing but here mg here. Okay, so work done becomes 6 joule, which is positive, remember. Now just observe what is the change in potential energy. Okay, what is the change in potential energy? The change in potential energy generally given by this notation delta U. So U final minus U initial is a change in potential energy. What is the initial condition? So this is the initial condition, this is initial condition, and this is a final condition. But initial, it has some height h. So final velocity, final potential energy is m. Okay, final potential is what? mgh or 0? Yes, final potential energy, there is no any height. So U final becomes 0 and U initial is what? It has some potential energy that is mg into h. How it has? Yes, we must consider in potential energy lecture, but now remember, as there is a body has some elevation from the ground, from the reference, so it has some energy in it, and that energy is nothing but mg into h. So what it becomes? Minus mgh. After putting a same value, we get delta U is equal to minus 6 joule. So delta U work done by this downward motion conservative forces. So what relation what observed? So work done by conservative force in downward direction, say WCD is, yes, is equal to, but what happens here? So that is equal to a minus delta U. So probably this relation is very important. Delta U is equal to minus work done by conservative forces. This is a conclusion from this example. That is, a change in potential energy becomes minus of conservative energy. So delta U becomes minus WC. बघा हे फॉलिंगचं एक्झाम्पल आपण घेतलं. इफ यू कन्सिडर अपोजिट एक्झाम्पल दॅट इज अ प्रोजेक्टिंग अपवर्ड. If you consider this projecting upward, again same. So work done for up motion is again same. So at this point velocity is 0, at maximum height velocity 0. This height is h again, and it started with this velocity 2 meter per second. So in this case, this work done for upward motion you can calculate. So see what is this mgh. As per the sign convention, that is minus, because force F downward, S is upward, S or H we can say. In this case we have considered S as a H. Okay, don't confuse about that. So WU is mgh, which is minus. So again it becomes minus 6 joule. Now think about a potential energy. So potential energy, change in potential energy, again U final minus U initial. What is the U final? Which is the initial condition here? So this is the initial condition here, and this is the final condition here. So initially there is no any yes, potential energy. So in that case it becomes U final becomes mgh, but Ui is 0. So we get mgh. Finally it has some potential energy, but initially it is 0 because there is no h. So this gives us mgh. Remember, again calculation gives us 6 joule. So what conclusion we have drawn here? So delta U again becomes minus W conservative, work done conservative. So in any case, I'm taking a two sample examples, but conclusion is what? So conclusion is, the first conclusion is potential energy difference or change in potential energy is always equal to negative of work done of conservative. And second conclusion we have drawn. If you add these work dones, W, yes, downward plus W upward, that always becomes 0. So this is important second conclusion. So this is very important relation. बघा याचा उपयोग आपण करणार आहोत in the conservation of mechanical energy. How to modify a work energy theorem in form of conservation of mechanical energy. Remember, conservation of mechanical energy, you need not to remember separately. Apply, I think always, apply work energy everywhere, but by considering change in potential equal to negative of work done. बघा आता हे कळणार नाही आपल्याला, पण आपण जेव्हा conservation of mechanical energy modify करू तेव्हा याचा उपयोग कळणार आहे. So conclusion of this all lecture is what is a conservative force and what is mean by a non-conservative force. So conservative force depends on initial and final position, does not depends upon path. And non-conservative force depends only on the path. Okay, and work done and potential energy relations gives us the change in potential energy is always a negative of work done of conservative forces. And one thing also remember, a potential energy is yes only applicable in case of conservative forces. Okay, how it is, let us think, but I will explain in potential energy during the conservation of mechanical energy why potential energy is only related with the conservative, not related with the non-conservative forces. Okay, so let us stop here.